All right, this is going to be AP Calculus, lesson 4-1. We are on tangent line equations. All right, so to begin with, we're given a point and a slope. So we want to review our writing an equation of a line in point-slope form. Raise your hand if you know what point-slope form is.
I feel like I remember. Point,
roughly.
and then you go point.
Point and slope. All right, so I need to somehow start with this information and then get a line out of this. All right, so if I have my graph set up over here, let's go ahead and graph the point 3, 2. So 3, I'm going to come over 3, 1, 2, 3. I'm going to go up 2, 1, 2, and there's my point. And I know my slope is 5, which means I go 5 up, 1 right. So I could go up 1, 2, 3, 4, 5, and 1 right. And then come down another -3, 1, 2, 3, go 1 left. And I'd get my line if I connected these dots. You only need 2 points.
Five up.
You only need 2 points to make a line. What was your question, Kaylin?
So you go 5 up from the 2.
5 up. What do you mean?
So like you go to 7, not.
Yeah, so I went 5 more up, so this is 4, 7.
Okay.
And then this is 2, -3. And then you could graph the line. So the general idea for how to graph a point-slope form is this. You do y minus the y-coordinate, so y minus 2, and I'll write the general form right after this, but this is the example, is equal to the slope, which is 5, times x minus whatever the x-coordinate was. The x-coordinate here is 3. So from a point and a slope, I can get an equation immediately without having to do anything additional to get to y equals mx plus b form. So here's the general rule. So in general,
Wait, why is it -3? Sorry.
it's always going to be x minus whatever coordinate you're given. This is always a minus by default. But if you had a negative coordinate for your x coordinate, it would be a double negative. When negatives kiss, they become positive, and it would be x plus whatever negative number this was.
So that's 3 is your y-intercept?
This 3 is not my y-intercept. This is
mx plus b? Or
this is not y equals mx plus b. This is a different form that we're setting up.
Okay, I was like,
This is called point slope form. Maybe we can write that on the side if we want. This is called point hyphen slope form. So in general, you're always going to have these things. You're going to have a y minus something there is equal to, this is going to be the slope, we'll label these boxes in a sec, times x minus the x coordinate. So we can label these. This is going to be the y coordinate.
Do you want us to actually draw those boxes?
Yeah. That lets you know that something needs to go in that spot. This is going to be the slope. So you can think of slope as either m from y equals mx plus b, but even better, what's the calculus slope?
derivative.
The derivative, exactly, f prime. And then in here, what did we say went in this box? Do you remember?
Other x coordinate?
The x-coordinate, yeah.
Wait, the x coordinate of what?
The x-coordinate of the point, because we were given a point that was in x, comma y, and this was our f prime. All right. So we only have 5 more minutes left of class because we went over the test. So I want to do one more slide, and then we'll do the examples tomorrow, and then the work in class tomorrow.
Yay.
All right, so our last slide is writing the equation of a tangent line. So now we're just doing a tangent line. So let's rewrite it all again. So this is writing the equation of a tangent line. All right, so the main thing to take away here is this is only going to be an estimate. And I'm going to start right off the bat by saying that. This is not going to give you an exact value. So I want to write that out exactly. So these can be used to estimate. Okay, my line needs to be better here. To estimate function values. I'm going to abbreviate function by saying FUNC, function values. And what do I mean by estimate? So let's go ahead and draw two graphs here. Or two coordinate planes, I should say. So let's pretend that we had some quadratic function.
Oh.
And I knew some information about this.
Ew.
So I knew
Oh my god.
at this point, let's say that this was, I don't know, x equals 1. I had a height of, let's say that, I need to write in a different color up here. Let's say that the height of this point was 2. Look, I gave you a point. X coordinate, Y coordinate. And I'm also going to tell you the slope. Very similar to what I just did in the last slide. I told you the point, and now I'm going to tell you the slope. I'm going to tell you that the slope at this point was 3. So we'll say the slope is 3. I'm just going to draw that roughly. And I should be using red for my derivative, and I messed up my color coding. But my derivative here is 3. That means I'm going to roughly say, pretend that that was a slope of 3. I know it's more or less than 1, actually. But let's pretend that was a slope of 3. I can estimate really close values to this function. By that I mean, if I want to find what the height is at 1.1, really close, it's only 0.1 away, I know that 1.1 is actually right here on the parabola. But it's going to be a little bit off, it's going to be a little bit below on our line. But the difference here is going to be so small that it's basically the same value. Obviously, if I took some bad value like 4, then it's going to be way off the charts. It's not going to be even close to this line. This line extends out like this, and we would get a value here, and it's way up here. It's like way off the charts. Obviously, if it's really far away, we can't estimate. But if it's really close, just 0.1 away, we can use this straight line that is the tangent to this point to estimate the value.
So how do we write that out?
So I think we can just digest that for today, and that can end this part of the notes. We'll finish the notes tomorrow and start on the worksheet tomorrow. All right, that concludes this part of the video.